Hey everyone, thanks for tuning back in. This is Eric, KJ4YZI with HamRadioConcepts, and this is going to be part one of many series videos to follow in the time that I get to complete this project. This is probably the first time I've ever built a project and documented it along in videos. And maybe you want to follow, maybe you want to do this together, maybe you just want to see if this actually works and I can get this thing running before you invest in it. That's great. But I really want to do this, and I was kind of scared a little bit to jump into something like this, but I want a project. I've always wanted to do a project. And I have this printed out, but we're going to switch to the computer and we're going to go through in this video and tell you what this is about, what it is, who designed it, where to get the parts. I'm going to buy the parts on the video and then source everything. And then in the next video, when I get all the parts, we'll look at what we have and determine how I'm going to start building this. So I want to build the autonomous satellite tracker. And this is in a published article in 2015 in the QEX bi-monthly publication for communications experiments from QST. Elwood Downey, WB0OEW, designed this satellite tracker. And what it is basically a two-axis tracker that needs no prior alignment with respect to Earth's surface and tracks satellites with high accuracy entirely by reference to built-in spatial sensors. And in this article, it describes the parts list that he came up with. A lot of it is based on Arduino components and Adafruit and can be found on Amazon and Servo City websites. We'll go through all that. But basically what's going to happen is you're going to, or I am going to plug in a satellite. I'm going to set this thing up outside with my antenna on it. And I'm going to set this up and plug in the information of the satellite I want to track. And this thing is automatically going to start tracking it at the appropriate time and follow it across the sky with high accuracy. Rather than me being out there with that arrow antenna trying to do this, right? That's fun. I still want to do that. I do not want to make this an FT8 of satellites, believe me. But it's going to be fun sometimes when I really want to get some contacts, when I really have a good pass and I don't want to stand out there and try to fool with the radio. I mean, the reality is it's a lot to do at one time with one mind, okay? You got to adjust on the radio and watch the radio, especially when you have a 9700. You got the waterfall there, you can see the satellite signal and you're trying to move it. At the same time, I got my camera over there going because I want to record it for you guys. Then I'm working the satellite like this with a hand and trying to write the logs down, or I record it and play it back later. So it's kind of hard to do at one time. So when I want to get out there and just make a contact with this tracker, that'll make it really fun. And if I want to get out there and really try a low horizon contact with a handheld antenna, I can do that too. But basically, this tracker has a GPS receiver on it. It has a 9 degrees of freedom sensor attached, so it knows where up, down, left, right is, you know, diagonal or wherever. And it's also got Wi-Fi built in with an access point you could find that's easily available. So you could remote into it with a laptop on Wi-Fi and plug in the information, you know, and maybe even run diagnostics, I'm not sure. But all you really need is the web browser to, you know, do that. All the parts are off the shelf. So this is the big thing for me. I don't have to start learning how to CNC machine parts. All these parts that he sourced are available online. And and I'll show you, because some people may say, I can't find when you said the, you know, Mega 2586, I can't find that. So I'm going to go through and walk through and show you the parts that I'm going to order. All the electronics are powered from a single DC supply, 7 to 18 volt, like a LiPo battery pack or a solar charging system. And the good thing about this project is I can actually tweak it a little bit to what I want. So I might use a Bioenno battery, or maybe I'll find a really cheap LiPo pack on eBay or Amazon or something with a couple different step-down transformers to feed the servos with 6 volts and the Wi-Fi router with 5 volts, and maybe a little portable solar charger that I can mount on the tripod so that when I'm out in the field it gives me a little more power if I'm going to track multiple satellites on one time. And I have the freedom to do that, and you have the freedom to tweak that however you want to make it, you know, your own little creation. All these parts and documentations are available online, and they're really no secret or patented any information here. But the goal of this video is just to document what I'm doing, because there'll be a lot of questions. What you don't know is with 57,000 subscribers, I get questions all day and I just don't have the time to answer them. I wouldn't recommend slamming this guy with all kinds of comments and questions about his design, because this guy has his life of his own. He just published this. I don't want to turn this into, hey, go to this guy and flood his email. That's why I decided to bring this into a video so I can answer the questions for you guys, because I really don't want to bombard this guy with questions. I'm not taking his idea. I'm not showing you anything different than what he designed or came up with. I'm just being the middleman here. Let's build it, and you can ask me the questions because I'm going to be the one building it, and that way he doesn't get flooded with the emails of what you want to ask him, because he's going to be upset if he finds out all of a sudden I flooded his inbox with emails. So let's keep that, into consideration. So let's go online and start looking for the parts that are freely available in a list, a parts list on here, and see what he decided to do and where you can find these parts. Shopping on Amazon is always fun. Even after a couple shots of Fireball, it makes it a lot easier to spend money. So we're going to go through and find as much parts as we can on Amazon, then I'll take it to the other site that has the rest of it. Now, this is from the published article, the bill of materials, and the price on here has come down a little bit since this. Some of the parts are just a tad bit cheaper and can be found on Amazon, and so it might end up being like $305, I guess. And that's not including the price of the tripod. So it depends on what kind of tripod you got. I got to shop for one of those as well. And also the battery and the little parts in between for, say, the step down transformers if I'm going to use a 12-volt battery and all that. So we'll get into that. I think we're going to order these first and then see, the project case and stuff, what I'm going to use as far as all that. Now, there's another site, and all these links are in the description. You have to look in the description of the video to see the links for each item that I found on Amazon for you, as well as this. This is another part of his website that's got the original published article, a block diagram, and some updates since 2015 or 16 when this was published. So a few changes have been made, and here's the software down here, different things to download for the Arduino libraries and stuff like that. So we'll start here on the bill of materials, because it seems that this is really the bread and butter. The first is the Arduino Mega 2560. Now this says Amazon Sunfounder, okay, and the thing about this is I'm not going to go cheap, okay. I can find that Arduino board for $1 or $2 less, but I'm going to take his judgment that the Sunfounder is probably the most legit, and I think the Sunfounder is actually officially licensed. So we're going to type in Sunfounder Mega 2560, should be the most popular here, and there it is, $13.99, and that's the same board that he recommends on his bill of materials, which has come down a couple bucks. All right, so I'm going to drop one of these in my shopping cart. This is Prime free 2-day delivery. We'll add that to cart. Okay, the next we're going to need is the Sunfounder Ethernet Shield W5100 for Arduino. And we'll go back up here and we'll just type in Sunfounder W5100 Ethernet. Should be enough to find that. And there it is, roughly $11.99. This is going to give you Ethernet capability on your Arduino board for connecting to the Wi-Fi hotspot that's in the project box that's going to communicate with you wirelessly to plug in the parameters for the satellites. So we'll get one of these at $11.99. Again, all these links are in the description for this, okay? And that's come down too. If you look, it's $11.99 and the price on his was $16. So we're saving money here. Saving money's good. The next, the Wi-Fi router, and there's a couple options for this. By TP-Link, he recommends the WR702N. So we're going to type that in, TP-Link WR702N. That, let's see, $37.49. What's he say his was? $20. So the price of those came up, okay? There are some other options, like I don't really think I need an AC router. This is like a portable router, a 5-volt USB-powered portable Wi-Fi access point. You feed it Ethernet into it, it becomes a Wi-Fi hotspot. So that's going to give you the Wi-Fi. Now, if you're creative, you can use an existing router you have at home. This is where I said this can get a little, change up. I actually have a TP-Link battery-powered router that does N300 speeds, and I could actually use that. It would stay charged via USB in the project box, and it's got a battery built in, but I cannot find it. So what's going to happen is I'm going to order this, then I'm going to find it, but I had this thing sitting here for years. So the cheapest one that I have found is about 30 bucks. Then there's this Who 2. Who 2, okay? Now the Who 2 actually looks exactly like the TP-Link, but it's probably a China junk. So for the extra $9, I'm going to buy the TP-Link because I've had good luck with them. And if you really want an AC portable router, which is 802.11ac, which is a 5 gigahertz or a wider, faster bandwidth, which is actually coming in a future Wi-Fi video explaining all that, you can go with this. I just need a wireless 802.11n 300 router. You're not really surfing the web on this thing, okay? So I'm going to go with this one for 30 bucks. All these so far are Prime. No, I don't want a protection plan. Okay, we're up to 55 bucks so far. The next is Adafruit. These are parts that go with the Arduino. Now, this is recommending Adafruit, and Adafruit is a big, Adafruit is a big supplier of these types of parts for those. And really, if you want to get, they sell on Amazon too. That's where I'm going to order because I'll have free Prime shipping. I'm not sure. I think they charge you for shipping on here. But if you're ordering from the authentic Adafruit on Amazon, it's the same parts. Adafruit's really big. You can get Raspberry Pis there. You can get Arduino. I guess tell them that you saw it here so that maybe they start sending me some pies. But anyways, so we're going to use Amazon for this. Actually, Adafruit part IDs. They're all different part IDs. Make it easier for the creators, Adafruit, to come up with the part ID. So instead of calling it a GPS module, you can look up ADA746 like this. ADA746. And that should give me right here the Adafruit Ultimate GPS Breakout. 66 channel GPS. Now what's the GPS for? GPS is for timing. It's also for positioning, and it's kind of really required. So I don't know if you can find an alternative for this, but this is actually sold, let's see, by Adafruit. Let's check it out. Yes, sold by Adafruit. $37.44. His article says 40 bucks. We saved $3 there. And this is going to be solder wires on here for the different configurations, between this and the Arduino. So, and also this is a version 3. So on his, at the time of his posting, this I guess was a version 2, which kind of looks the same, and you could probably find a version 2, and it would match what's in his article, but a version 3 should be the exact compatible. It's just a newer board design by Adafruit. So we'll add that to the cart. We're up to 92 bucks. And how do I close the cart? There we go. Okay. So far we've knocked out 4 of these. The next one is the Adafruit 815. That's the servo controller. So that would be ADA815 if you're searching this. And again, to make this easy, just go in the links in the description, and all these are already found for you. ADA, what was that? 815. 815. I think one of these I cannot find on Amazon. This one I can. This is the servo driver, sold by Adafruit, the 16-channel 12-bit servo driver, which is what he has here. He says his was 15 bucks when he ordered it, and this is 20 plus free shipping. So we're going to add this one, although this one is not Prime, so maybe not totally in stock. Do they have more? Let's see. This one's Prime. What's the difference between this? This one's sold by Adafruit as well. This one's $16.95 with a free Prime. PID 815. So that should be it. The servo controller, right? Yeah, servo controller. We're going to add that to cart. Okay. You saw now there was another one that was $4 more without Prime. So you got to look for these deals. The next one I think is the I forgot what DOF now stands for. I said it in the beginning of the video. Now I'll have to look at it. It is the degrees of freedom. That's right. So the ADA 2472, I think this one I cannot find. ADA 2472. Yeah, this one is going to be Adafruit DOF. I think I can't find this one on here. Let's see. 3387. This one looks like it is it. This would be the 2472 model number. That's it right there. Okay, so this is sold by Adafruit with Prime, $34. His article said $35, so that's about the same price. This is your orientation sensor, so that it knows which way to point the satellite. Okay, 9 degrees, up, down, left, right, 1, 2, 9 axis. All right, and you can see also it's got the solder tabs or points on there, whatever you call those, before we get it connected. So we will add that to cart. Right now, no, I don't want the equipment protection plan. Right now, we're up to 143 bucks. Now, that's all on Amazon minus the tripod. Let's go look for a tripod now. I'm going to go looking for a tripod. So I'm just going to, I don't know, type in camera tripod. There's probably 1,000 of these things. And the quality, so what you're going to have to figure out based on his article is on the tripod, all camera tripods have that, you know, what is it, 1/4 inch screw on the top where you would attach your camera. If I could see it. You see it's got like the screw up here, okay? And every one of them should have that, but every tripod's going to be different. I would stay away from these Amazon Basics. They're too lightweight. I have one which is actually holding my camera in this video. Except mine says Kodak on it, but it's the exact same thing. It's just a cheap tripod. You want to have a tripod that's not going to blow over in the wind. So, we didn't pop up with too many. There we go. There's a lot of different options here. So, I think you won't see me buy the tripod in this video because I have to really look and see which one's the best. His tripod, in his article, looked like this. Okay, so he did look like he had a Amazon Basics. And his manufacturing skills that he recommends is only in this entire project is connecting all this to that tripod. That's going to be your challenge. I guess you can buy this channeling from Servo City, and I'll show you that in a second. That's where you're going to come up with a little bit of creativity. And he said of the entire project, that was his hardest problem, or hardest thing, was determining how to securely fasten this to the tripod. So I'm not going to order the tripod in front of you, but you can see I might end up going something with, I don't think I need a, Vivitar $6,000 fluid mount, but we'll figure it out, maybe like a $40 or $50 one telescopic with a wide base. The antenna's not that heavy, but I don't want the thing blown over, and it really doesn't have to really move so much on the top of the tripod. The movement's happening up here. It just needs to hold this thing straight. So I'll try to find a tripod for a camera that just stays without having a moving head, probably. All right? So we'll skip that. The next part that we need, and of course I'm going to have to find this, I know where I'm going to get one of these boxes. I'm going to go to Skycraft in Orlando. Again, video coming up. Like the largest place in Orlando with absolutely every single piece of electronic known to man in boxes and racks and shelves. It's well worth the video. You got to check that out. I go in there all the time and just spend money on all kinds of stuff. This right here, Servo City. Servo City is a big supplier of different things for robotics, for RC. They have a lot of different stuff. And you can see they have a lot of CNC machined gears and motor controllers and all kinds of stuff. All right. So what's funny is if you go here and you type in WB0OEW, you should get, let's see, where is it? I know it was here. There's a way, let's try Googling. It comes up on Servo City, WB0OEW. Let's try this. Here you go. Project on Servo City. So they're hosting the project here, and it will actually, you can add the two parts right here to the cart. These links are all in the description. It does give you the Adafruit part numbers and all that for what we just looked up, but those are all available otherwise or other places. This, if I go here, it kind of gives me an idea of what this is. This is what you saw in that published article. And if I click add parts to cart, it's going to put in the 2 parts that I need from Servo City, the servo gearbox and the tilt system. The price compared to his article, the 5-to-1 ratio platform here was 100, and that still is 100, but the other tilt stage, $95, is now $69. So this came down, the tilt system came down in price. So these are the 2 SKU numbers, and I'll have a link individually for each one of those in the description. You can just click in there and add them to cart. So these are 169. So if I go to calculator and I add up my parts right now, 169 plus how much on Amazon? 143.39 minus the tripod. 143.39. So we're looking at $312. That's about $30 less than his published article. If you're still watching, it's worth mentioning that you do not have to be one of these crazy 15-year serious DX contesters with every bit of equipment known to man to do this. You can be a newly licensed technician class with a Bofeng UV5R handheld. And you can do this in your driveway. You don't have to be an engineer or an extra class or even a general class. Technician class, it was in your exam. You can work satellites on VHF, UHF from your driveway, either with a handheld antenna or something like this. There are ways of doing it more advanced, like I want to build here, and there's ways of doing it on the budget. So don't think that this is the only way of doing satellites. At the same time, you can use this to get together with your club and make it a group project, a group effort. You can also do this with the school that you're affiliated with. Maybe you got a school event that you're involving kids in working the International Space Station and getting them involved. Robotics class, even the Boy Scouts on the air. I mean, there's so many different possibilities. Instead of doing this for yourself, you can make this a project to involve a lot of people to do this, okay? So that's that for now, and that's more on satellites coming in the future. So one more thing I just want to show you. I think I'm done ordering parts for now because I have to see what I get and then draw up some stuff. I like to think when I sleep. I go to bed thinking about this stuff in my head, you know, how to make the next video, how I'm going to make this tracker and stuff like this. So step-down transformers is something I'm going to have to find for, 12 volt to 5 volt, and I don't know what I would even search for. 12 volt to 5 volt step down, maybe. I mean, there's a lot of different, ways of doing this. Like you have right here. Here's a DC-DC converter. That's right, DC-DC converter. We use DC-DC converters at work. So I could put 12 volts into this and get 5 volts out. Another one like this here, 12 volts in, the 5 volts out. I mean, I got to figure out which ones I want to do. And then I need also 12 volt to 6 volt for these servos. So there's a lot of different power converters and step downs and stuff like this in order to take a 12 volt lithium ion or a bio-NO or something and, be able to split the voltage accordingly to different parts of the satellite tracker. I'm not going to go cheap on these parts if I find something, and I know Skycraft in Orlando has some. I've picked them up before in my hand. It just, you have to weigh out, and even, do they have bio-NO on Amazon? I don't think so. They might. Yes, they do. So if you're thinking about a bio-NO, the one I have is this right here. That'd be pretty much too big for that. That runs my HF radio at 100 watts. I would want something small, like the little 3 amp hour here. Maybe crimp some power poles on there to make it easy to disassemble. Maybe even this little one here. Something small. Then I could use a solar charge controller with my solar panel mounted on it. I'm not sure what I want to do there yet. But you don't need a Gigantor battery to run this thing. Especially if it's a lithium iron phosphate battery like this. But lots of different options. Just be aware of the cheap knockoffs on eBay they look just like a bio-NO without that sticker, and I've heard a lot of reports about those having problems where they really don't put out what they say they put out. You draw 5 amps on them and they shut off. So just be aware of that. Okay, so the parts are ordered, and this will be part 1 of several videos. You could probably put this together, from my understanding, you could put this together in probably a day if you were a really good guy with projects and stuff like this and you had parts laying around. I want to span this out to several videos so that you can see the progress, and I don't want to rush it, and I got a lot of other things I want to do in videos, so I don't want to stop everything and just focus on this. So I hope to put at least a video up once a week about the progress, and at the end, if you see that this turned out good, which I'm hoping, and you say, wow, I want to build that too, don't thank me for this design because it is actually Elwood's design, and don't flood his email, but just keep in your head, thanks for him coming up with an article like this that's this easy for us to build. I've never done a project before, and I was nervous reading this, like, nah, that's over my head, but really, it looks like it's rather easy, and it'll be fun for you to follow along on this project. So, until next time, keep an eye on it, subscribe so that you get the notifications of when I post a video about the satellite tracker. If you have any questions, I'll try to answer them, and hopefully the website's finished by the time this is finished, where I could put pictures of my progress on my website. You can visit HamRadioConcepts.com. It's still under construction. I'm not the most creative person on building websites, but I've started it again, and I hope to have all the progress updates of pictures and my thoughts in there so you can follow along and see my little hints and tips and tricks of what I've done, and that will help out. So 73 KJ4 YZI.